Today we will talk about the inclusion defects. First, we will talk about the theoretical outlines. Everything which is non-metal you can find inside a metal alloy is a inclusion. We can divide this into 4 parts. First one is inclusion of investment. Second one is inclusion of graphite. The third one is inclusion of oxide. And the last one is inclusion of abrasives. So, how does the defects disappear? So, we have to learn about the problem to solve it by learning about the necessary theoretical to provide it and understand the machines. So we will talk about how to defects disappear in investment inclusions. This shows that we have to learn about the theoretical of speed that the liquid metal can do. First is the parameters are the kinetic, viscosity, speed of the UAD and channel diameter, the equal capacity of liquid metal inside the feeders of the mold depend on the features of the motion triggered of the dimensionless parameter exact called number of Reynolds, which of the features of the liquid motion are defined according.
The picture is an example for investment inclusion due to the use of an expired investment material. Another sort of defect connected to the investment is when a root surface is obtained which is associable to the information for gas together with the crest on the angle of the casting. In fact, the main cause of this defect is in the melting method because the higher is the pressure which pushes the molten metal in the mold. It is a common practice to use some tack to facilitate the release from the wax model for some kind of rubber. An active pink picture is a surface porosity caused by the use. The final result will be to obtain a very high surface porosity of the piece. Avoid such do not use thallic and have to use the scrap wax. If not, the tat is embedded inside the wax with the chance for fixing problems or release incursions in the final casting. Graphite incursions. Crepicals are usually made of graphite, carbon which is the most stable thermodynamically speaking under environment conditions and display a structure of the hexagonal thin plate act according to the base. And we can say that the parameter which mostly influences the presence of inclusion inside the material is the number of reuse of the crepical itself and of all the elements of the casting machine made of graphite. On the right picture is a graphite inclusions. After continuous casting and excessive use of the crepical increment the probabilities of finding inclusions of graphite inside the semi-finished product. When possibilities, it is advisable to do a casting in inert atmospheres, for example, by using nitrogen or argon, a solution which can be used only if vacuum casting machines are utilized. Oxide inclusions. Oxide inclusion and oxide is the product of the chemical reaction between the element and the oxygen called oxidation. Usually by looking at the microscope, you can see on section oxide inclusion. Of course, each time the material is reused, you have an increment for the quality for the present oxide. This type of defect is for phase. When oxide metal is used or when the correct precaution have not been taken to avoid the oxygen absorption while casting. The sleeping agents used as poor and the particle for adhesive does not come always easily in the way. Borax is the most important used as fast as the consent the glow alloy. The use for vacuum casting machine for use quarantine the appearance for the problem away after several casting. In fact, a glass and uncolored asper indicate that there are not oxide metal. When a green and blue color mean a present for a copper oxide and a gray color indicates a present for zinc or cadmium oxide. If open machines are used, the use for the oxide can help to reduce the quality for the oxide, which cast up after casting is embedded in the metal.